In this video, I'm going to demonstrate how to set up the vector data processing pipeline. So as you can see, I added the four vector data layers in my geodatabase. And the first step, as you can find in the workflow, is to project the layer. And to project the boundary layer, I'm going to connect the boundary feature class with the project tool. Then we want the user to insert their own choice of coordinate system. So that's why I'm going to create a variable called coordinate system and assign the name, assign your output coordinate system, so that the user can choose what type of coordinate system they want to use. In this case, we know that we're going to use or import the coordinate system from the LULC layer. So we'll go to the import coordinate system and navigate the geodatabase to find the LULC veggie, and in here you can see under custom it's added, and I'm going to quickly add to the favorites so that I can find it again later, and then I'm going to assign that as a parameter as well. Now I'm going to drag and connect it to the project tool, and that's how I'm going to set up my project tool with the boundary and reproject it to Albers equal area conic. Now I also have to rename each project tool because there are four of them, and I'm going to create the same process for all four of them, so I don't want to get confused which project tool is for what layer. So let's just rename each of the tools. So this one is project roads, this one is project boundary. And while we are renaming, we should also rename the output data set, because again we are going to create a bunch of output data set or feature class, so it's a good idea to rename so that again we don't lose track of which output is from what tool and for what data set. I'm going to assign each of the feature class as parameter so that the user can insert their own feature class, and then also rename these parameters as something nice, such as input park boundary feature class, so that when we click on the pop-up window, it's a nice instruction, and it's user-friendly instruction, so that the user not only know what layer but also what data type should be inserted. So all the feature classes are renamed here in this input data set and also assigned as a parameter along with the output coordinate system. And if you want to open the interface, the GUI for the model, this is what you see. All the renaming that you did is on the top of that option where you can insert your feature class, and also I clicked on the auto layout button to lay out all the tools nicely so that it's more organized. And I'm going to add the next tool in the pipeline, which is the buffer tool, and that's just for the boundary layer. So I'm going to use that projected output from the boundary layer as one of the input data set, and here I want the user to have the distance as a parameter, and so that they can choose whatever distance they want for the park boundary buffer. They don't have to stick to our distance, which is 5 miles, so that's why it's important that we assign that as a parameter. Once that's assigned as a parameter, rename that and make sure the output feature class name is right and dissolve type should be single feature. We are going to assign the boundary distance ourselves, which in our case is 5 miles, and then click OK, and the buffer tool is all set. Then for the next step, for the rest of the three feature class, we have to use the clip tool. So I'm just going to copy paste the clip tool 3 times or 2 times after inserting, because it's kind of the same task. I want to connect it to the 3 feature classes. So the first one is the road, where it's the input feature class and the clip feature class is the boundary project buffer. And again, I'm going to rename the tool so that I'm not confused which clip tool belongs to what layer. And I'm going to also rename the output feature class from the clip tool. So the second one is the stream, where the clip feature is project buffer, and then renaming the tool. Once that is done, the next step is to add the distance accumulation tool. Keep in mind that we are although adding the distance accumulation tool for the road, streams, and water body in the pipeline right now, but I'm going to pause after I add the tool and add the LULC and DEM before I set up the distance accumulation tool. Here I'm going to attach the clipped road layer as an input raster for the distance accumulation tool, and the boundary buffer as the extent of the distance accumulation. Remember, we have to define the processing extent, and we are also going to use the same layer as a mask because we don't want it for the whole layer or the whole area, but for the masked area. Before we do that, one thing to remember, that I'm not going to set up the whole distance accumulation tool right away. I'm going to wait till I add my LULC and DEM, because I'm going to import the cell size from the LULC layer, and also going to use LULC as a snap raster for the distance accumulation tool. So you can set up the distance accumulation tool and then go and do the LULC DEM part, but come back once you're done with setting up the raster layers. Come back and connect the distance accumulation tools here in terms of cell size and snap raster before you finish this part of vector data processing pipeline.